So in method 2, I am going to show the same curves that we saw in the method 1. So basically for method 2, let us draw the curve y is equal to x square, then the line we'll draw with a different color. The line x plus y is equal to 2. Let me show that line by this. Okay, so now we have to consider the region of intersection. The region of intersection over here is clearly what? It is the area under this green line. Now if we take a vertical strip we have done in method 2, now the region of intersection over here will be the whole area, right? So now if I consider a vertical strip, let me consider a vertical strip. So if I consider a vertical strip, the region down touches to the red line and the region of the vertical strip touches up to the blue line. But now if I take the horizontal strip, the strip touches left to the parabola y is equal to x square. The strip touches right to the parabola y is equal to x square. It will go from down to up. Again same, it touches the parabola. Then after some time it will go up. Here you can see the strip touches left at the parabola, but the strip touches right at the line. Again it goes up, same. So clearly the limit are changing. Here it touches the parabola and when it goes up it touches the line. So taking the same region of intersection won't work. So we need to divide this into two regions. Let me shade this two regions by two different colors so you will understand what are the two different regions. Right? So this will be one region. And now the another region that I need to take is this. Right? Let me write this region R1 and R2. And I take a strip parallel to, okay, I take strip parallel to x-axis. This yellow one is the region R1, this yellow 2 is the region R2. Points I have already found here up. Let me see what are the points that I have found out. This was -2, 4, this was 1, 1. So we can take those points over here. Okay, and this is obviously the origin. So if I consider now the integration to be carried out obviously will be with respect to x. We have considered a horizontal strip where the right end shifts, the curve also changes. So the movement is vertical here. So let us see now the integrations. First we will see over the region R1. That is the yellow part that I have shaded. So over the region R1, the ends of the horizontal strip touch the parabolic arcs. You can see in the region R1, here it is touching the parabola, here also it is touching the parabola. So the points of the parabola, what is a parabola? Y is equal to x square. So the value for x will be plus minus under root of y. So here it will be minus under root of y. And here it will be plus under root of y. Okay. So points on the parabola for which x varies are from minus under root y to plus under root y. And if the movement of the strip vertically, if you look at the y point, it goes from here to here. The y value here is 1 and the last over here y value is 0 and here it is 1. So now the limits, let me consider this as I1 because we have taken over the region R1. So the limits will be, first, since the strip is taken parallel to x-axis, the limits will be in terms of y and we will integrate with x first, right? So lower limit will be minus root, sorry, not here, it will be minus, and upper limit will be plus root y. Okay, and now if I consider the outer limits, the outer limits are going to be constants. You can check the strip travels from the region. So if I see the strip traveling vertically upwards, the outer region has the points 0 and 1. Okay, so this is over the region R1. Now we'll see over the region R2. Over the region R2, look at the region which is shaded in blue. Here the strip is touching the pink curve. What is the pink curve? Here we saw it is minus root y. And here it is touching the green line. Green line is what? What is the equation of the green line? X plus y is equal to 2 is the equation. That means the value for x will be 2 minus y. So my upper limit will be 2 minus y. Lower limit will be minus under root of y. Now the strip travels from down to up. So down the value will be 1 and here up value will be 4. So this will be my outer limits. So over the region R2, your I2 will be over the region R2, right? So that will be y dx dy. So the limits of integration will be what? Since you know that the strip is parallel to x-axis, we will integrate with respect to x first, and the limits are for x is equal to, the strip touches the left hand side to the parabola and to the right hand side it touches the line, and here it travels from 1 to 4, right? So this is my I1 and I2. So my final integration I will be the region I1 plus I2. So it will be double integration over A1 and double integration over A2. I mean region R1 and region R2 you can write. So we have considered the region R1 and R2. So the limits, final limits of integration will be 0 to 1 minus root y to y dy dx. Here the second integration is 1 to 4 minus root y to 2 minus y dy dx. So I leave you this sum for evaluation. Since we have done the method 1, by the same method you have to evaluate these two integrals and then you have to check. The answer that will be is same as the method 1. So even if we take vertical or horizontal strip, the answer won't get altered. Okay, so this is the result. We leave it as an exercise for a student. Fine. Now let us take one more example so that the regions will be clear to you. Here I won't give you integrand, so this is just for your practice. So this is evaluate double integration. Let me take any function f of xy. No need to solve the integration, right? So you just need to know how to find the limits over here. So evaluate, this is the integration over the region. what are the curves here? In the first quadrant, enclosed by a rectangular hyperbola xy is equal to 16, and the lines y is equal to x, y is equal to 0, and x is equal to 8. Okay, let us, as we know, we need to draw the curves first. So first let us draw a rectangular hyperbola xy is equal to 16. So xy is equal to 16, we can draw like this. Okay, y is equal to x. You know that y is equal to x is a line which passes through the origin. So this will be y is equal to x, the green line, right? Next, y is equal to 0 we have already drawn, that is my x-axis. And one more thing you need to draw is your x is equal to 8. Now x is equal to 8, x is equal to a is a line parallel to y-axis. So somewhere over here it will be. One minute. Okay, so x is equal to 8 is a line parallel to my y-axis. So clearly the shaded region is what? Under these curves. So this is my shaded region. I have to find the area of intersection over here. Now let us consider the point. Let us consider a strip which is parallel to y-axis. Now look at this. If I consider this strip, now look at this strip. This strip touches lower end to the axis. Up it touches to the green line. When we move further, that if the strip goes from left to right, here see now the strip will touch the lower end to the x-axis, but upper end it is changing, it is touching to xy is equal to 16. That means the regions we need to divide. So let me shade the regions with two different colors to show two different regions, right? So let me divide the region as this. This is my one region, and totally which is in yellow is my another region. I name that region as R1 and R2. Since the limits are changing, we need to take different integration. Let us find the points of intersections now. Here, this point and this point, right? So obviously this point is going to be origin. Now the point of intersection over here, that means we need to find the point of intersection of the green curve y is equal to x and the point of intersection of the pink curve xy is equal to 16. So how to find the point of intersection? We substitute one curve into another. Clearly we are getting the values of x and y, right? And here you know that x is equal to 8, that is given again. So y is equal to x, the points will be x square is equal to 16. So x is plus minus 4. But since it is in first quadrant, the x value will be 4 and y value will be 4. So the point of intersection that I get here is 4, 4. So I've got that point. Now this point is what? The pink curve xy is equal to 16 and the blue curve x is equal to 8. So if I substitute, I get the point 8, 2, right? So now this point is 8, 2. So I have got the point of intersections as well. So now integration we will see. So for the region R1, since the strip is parallel to y-axis, we will integrate with y first, and we have drawn the vertical strip. But since one vertical strip did not cover the entire region, we divided into two parts. So integration also will be done into two parts. So let us take the sub-region R1. The strip starts from x-axis and it ends on the line, green line. The green line is y is equal to x. So the first integration, again, we don't know what is the function. So we are writing just y is equal to f of xy. The first integration will be, the limits will be for y. So it is touching the x-axis, y is equal to 0. And here it is touching y is equal to x. Now the strip will travel from left to right. The x coordinate here is 0. It goes here and it touches up till right. It will travel in this direction. So here the x coordinate is 4. So my lower limit is 0 and 4. Right? So I have got the first integration. Now let me see for the region R2. So for the region R2, my second integration will be again same. The function f of xy is unknown to me, so we need not integrate for this sum. The limits for y is equal to, now if we look at this, the strip starts from x-axis. In the region R2, the strip starts from x-axis and ends at the pink curve. Pink curve is xy is equal to 16. So value for y will be 16 by x. So 16 by x is my upper limit. And then strip travels from left to right. So if it travels at the left, the value is 4 over here and the value is 8 over here. So lower limit will be 4 and 8. Right? So this will be my second integration. So my final integration is I1 plus I2. So both the integrations, just add whatever we have got. So this will be I1 and 16 by x, f of xy, dy dx. This will be I2, which is my final answer. Right? Evaluation is not necessary since the function is not given. So I just hope you are through and you have understood very well when to divide the regions. Always remember, if the single strip does not cover the entire region, we need to divide into two sub-regions, right? So we have taken two sums where we had divided the regions, and I just hope it is clear to you. So in the next lecture, we will study the order of integration now. Thank you.